let's do this nice and simple. Topic number 1, friction force. Friction force is pretty simple. Friction force is the force that retains an object and a sliding object. This topic is firmly related to our experiment, in which we will see an object being retained from falling through the inclined plane. In our experiment, we are going to see an aluminium object sliding through a piece of wood. To make it more simple, we used a tree that it was inclined. We were lucky, didn't we?
The normal force is the support force exerted upon an object that is in contact with another stable object. For example, if a book is resting upon a surface, then the surface is exerting an upward force upon the book in order to support the weight of the book. On occasions, a normal force is exerted horizontally between two objects that are in contact with each other. For instance, if a person leans against a wall, the wall pushes horizontally on the person. Basically, that's the normal force, and a way to get the name smaller, it's F, and that's to put a norm.
Well, I'm going to define what is a net force and the weight, which both are forces. And this is why, because the net force is only the sum of all the forces. But to have the sum of all the forces, we need to decompose each forces in by decomposed forms like x and y. And those x and y, we sum it every one by one singlet, and then we sum their squares and give the square root to have the net force. And the weight is the force that the gravity exerts on the mass of the objects. Like if I mass 80 grams, that means that 80 grams times 9.8 is the weight that I have, the force that the earth gives me.
Hello, my name is Xuali Peña, and I'm going to talk about the coefficient of kinetic friction. When the force applied to an object is greater than the maximum static friction force, the object moves. The friction force does not disappear, but acts on the motion. So the force that opposes the motion is called kinetic friction. If we add the forces along x-axis, the force will be similar to the previous one in the body moves with constant speed. The kinetic friction force is applied to the compression, which is equal to the magnitude to the normal force exerted by the plane on the sliding object on it. So, kinetic friction equals the coefficient of kinetic friction times normal force. Now, we're going to find the coefficient of the kinetic friction. First, we have our data. This is the height, the angle, the first mass, the second mass, the third mass, and the acceleration. And here's what we are missing. That is the coefficient of the kinetic friction. This is the force equals mass times acceleration. And we're going to do the same for each mass because we have three different masses. Then, now that we have the force, we're going to use the formula Fx equals the force times the cosine of the angle. And to find Fx, and with the same, the three different masses, because each one have different force, and the same with the Fj. But this time is going to be the sine, not the cosine. Now, we're going to use the formula. The same formula is going to be for the W. Now we are going to use the formula for normal force, that is W minus Fj. And the same, three different answers. And then finally, we're going to use the one with the coefficient of kinetic friction. That is the Fk over Fn, and we know that Fk is the one that we got from this. No, this is for the for the normal force, and the Fk we got it from before. And now we do the division, and we have the three different coefficients of kinetic friction.
So kinetic friction is the force that acts between moving surfaces. This kinetic friction is applied by the third law of Newton. The magnitude of the force depends on the coefficient of kinetic friction between the two kinds of material. This means that depending on the material, the kinetic friction will be different. So another thing that is important to remark, the kinetic friction is less than static friction because kinetic friction is not greater than the applied force when we start moving an object, which increases the static force to prevent any motion. Another thing is that an object that is being moved over a surface will experience a force in the opposite direction as it is moving, like the third law of Newton. So, saying that the coefficient is mk, and the formula used to represent it is normal force over weight. In this part, we can see the weight, the fact that we had about our experiment. The formula used for this is normal force over weight to calculate nk. So having that in mind, we have that US is equal to 0.2. With that, we can take out the normal force. Well, the normal force is calculated by the angle that causes because it's inclined in the x direction, that is 85 degrees, over gravity, that is 9.8, and finally mass, that depending on the object, it will be different. So with that in mind, we have that U and K, we can see that in all cases, the same coefficient is applied. Why? Because all the objects has the same material, the difference is the mass only. And with that in mind, we have that no matter the mass, in all the cases, it will be the same coefficient.